Today's lesson is called Distance in the Coordinate Plane using the distance formula. So let's look at the right triangle formed in the previous lesson a bit closer and how the lengths of its legs are related to the coordinate points. The diagram of the right triangle you drew in example 2 is shown below without the grid. So I took the triangle off of the grid that we did on the previous lesson and put it here, but labeled the points with the coordinates that we had found. So my first question to you is how can you get the length of AC to equal 6 using the coordinates of point A and point C instead of having it on the coordinate grid and being able to count it? Then in part B, I'd like to know how can you get the length of BC to get and B4 using the coordinates of BC instead of being able to count them on the coordinate grid. And then lastly, what I'd like you to think about is using what you learned in part A and B, how do you think you could find the length of AB knowing what you discover in part A and B? So at this time, please pause the video and try those 3 questions yourself, A, B, and the think about it, and then resume the video to go over the answers with me. All right, now that you had a chance to try on your own, let's look at it. So if I look at the distance from A to C and I see that it's 6, and I look at the coordinates and I see 3, 2, and 9, 2, it's the 9 and the 3 that gives me a 6. I can get 6 if I do the 9 minus the 3. The x from the second coordinate minus the x from the first coordinate. So I want to subtract those x values. Then in part B, if I look at why BC is 4 and I look at the coordinates, the way that I can get 4 is by taking the y coordinates and subtracting them. 6 take away 2 would be 4. So the y2 minus the y1, so the y from the second coordinate minus the y from the first coordinate would end up being 4. So in the think about it question, using what you learned in part A and B, how do you think we'd have to find the length from A to B? Well, the x's are changing and the y's are changing because it's a diagonal line, not horizontal or vertical. So you would have to subtract both the x and the y coordinate values. In addition to that, we are working with a right triangle. So we're going to take what we learned about a right triangle, a squared plus b squared equals c squared, and know that we can find missing sides by taking the square root once we get down to the end, and the information that we learned here about how we can find the lengths of sides using the coordinates, and we're going to put those two things together and learn what's called the distance formula today. So to find the distance between 2 points when they are not on the coordinate grid, we will use the distance formula. And the distance formula is given there to you. Distance is equal to the square root of x2 minus x1 squared and y2 minus y1 squared. And again, think about where this is coming from. You know from up top that we have to find the difference in the x's for the horizontal distance. We have to find the difference in the y's for the vertical distance. So knowing what we know about Pythagorean theorem, if we take those two distances, square them, add them together, and then take the square root, we end up with the hypotenuse, which will be the distance between the diagonal part that we can't find. That's where that formula is coming from. I want to show you how you can use this formula to get the answer of the distance between 2 points since we do not have a coordinate grid that can help us. So the first thing you want to do, and the steps are written on the side, is see the question says find the distance between the points -2, 10 and 6, -5. So first we want to write down our 2 coordinates and we want to label them correctly with x1, y1, x2, and y2. So I'm going to write down the coordinates -2, 10 and 6, -5. And then we are going to label these. So first of all, let's think about what coordinates are labeled as, x, y. So I'm going to put an X where the X should be, and I'm going to color code these just so later when you're watching you can see where the numbers are going. If you'd like to do the same, you can do that. You can also use highlighters. Okay, so I know X's are in the first position, and I know that Y's are in the second position, always, because coordinates are always x, y. We've been reviewing our coordinates recently. Now, the little numbers that you see on the bottom right corners are called subscripts. They're not exponents. And all that's telling you is that there's x's and y's from a first coordinate. So our first coordinate's the one on the left, so that will be x1 and y1. And the little 2's are telling you that that's from the second coordinate. So we'll do x2 and y2 here. We have to put the little numbers in the bottom corner because if we just say x, you wouldn't know which one I was talking about since there's 2 points. So now that they're labeled, my next suggestion would be to draw the outline of the formula, leaving a space blank for us to put the x1, y1, x2, and y2 later. So I'm going to do the outline only. D equals, I'm going to make a big square root line, parenthesis, I'm going to leave a space for x2, put my subtraction sign, leave a space for x1, close my parentheses and square it, plus my parentheses, leave a space for y2, draw my subtraction symbol, leave a space for y1, and square it. So I would always, always, always suggest that you draw the outline because if we have to put negative values in like we're going to have to do here, it's very easy to lose one of your signs. So now we can fill in the values from our coordinates into the appropriate places in the formula. So the first thing I'm supposed to write in the formula is the x2 value. So the x2 value was the x from the second coordinate, which is 6. So that goes here, and I'll color code for you again so you can see where I'm picking from. In the second blank should be x1. We're finding the difference between the x's. So x1 is a -2. Do you see how I could have easily dropped that sign if I didn't already have the outline? Then the next one is y2. So that was -5. And then the last blank I should be filling in is y1, which is 10. So now that I have it filled in, I can just do the math. The first thing I want to point out is that in this first set of parentheses, we have double negatives. So we have a double negative that actually changes to positive. It's very important you do not drop the parentheses until it's appropriately timed. We have talked a lot about the fact that if you type -2 in and square it without parentheses, you get -4. If you type -2 in with parentheses squared, you get +4. So those values are going to change if you drop your parentheses. So what we end up here is with D equals the square root. 6 plus 2 is 8. We're going to keep the parentheses squared plus, in the second set, -5 subtract 10 would be -15. Again, we are keeping the parentheses. I'm going to make a little note, keep parentheses, right? Because at this point, +8 squared would be the square root of 64 plus, if we didn't keep the parentheses, we would get the wrong answer for the next part. -15 in parentheses squared means -15 times -15, which is a +225. When we add those two things together, 64 plus 225 gives you 289. And if I were to take the square root of 289 on my calculator, I'd get 17. So the distance from -210 to 6 -5 is 17 units long. I used the distance formula since I had no coordinate grid to use in order to use Pythagorean theorem, but we talked about how that formula is extremely closely related. Now let's take a look at the next page. I wanted to give you this graphic that just shows yet another example so that you could use it to do the try it on your own problem. The one thing I'd like to point out about this problem in particular is that it got a different result than what we got. It got the square root of 30 as their second to last step, 130, sorry. And for us, we got the square root of 289. What was nice for us is 289 is a perfect square. So it's a rational number, and when we take the square root of 289, we get 17. In this one, 130 is not a perfect square. So we should have known before we even went to our calculator that it was going to be an irrational number. So do you see the squiggly before the 11.4, the equal sign that looks squiggled? Remember, that means approximately. So this question must have been an example where they had to round to a certain decimal place. So I want to make just a couple notes about this before you do the try it on your own. So we're just going to draw an arrow. And the first note, you can get irrational numbers, just like when we were doing Pythagorean theorem. And then remember to follow the directions of the question. So the directions are either going to ask you to keep it exact, or they will ask you to approximate, which means you'll have to round. Exact means you leave it as a square root, okay? So at this time, I'd like you to pause the video and do the try it on your own problem. I'd like you to find the distance between the point 72 and negative 511, and then you can resume the video to go back over your answers with me. Now that you had an opportunity to try on your own, here's the answers. The first coordinate is 7, 2, so 7 is your x1, 2 is your y1. Your second coordinate was negative 5, 11. So your x2 is negative 5, your y2 is 11. You can see in the first step, I wrote the formula. Then you don't see me doing it in action, but that second line, I made the outline of the formula. And then you can see I color-coded and filled in the values of x1, y1, x2, and y2, where they go in the formula. I then found that negative 5, take away 7 is negative 12. Keep that negative 12 in parentheses. 11 subtract 2 is 9. Negative 12 in parentheses squared is 144. You should not have gotten negative. If you got a negative 144, you didn't put the parentheses. 9 squared is 81. 144 and 81 is 225. So you get a nice perfect square. So it's going to be a nice rational number. Square root of 225 is 15. So for the last part of our lesson, I would like you to complete the closure question. Circle the method you would use to find the distance between 1/2 negative 3 and 4 3/4. I'm not asking you to actually calculate this distance. I want to know which method would make the most sense, and I'd like you to explain your choice on the lines to the right. At this time, pause the video, complete the closure question, and then return to the video to see the answers. So for our closure question, the method that would make the most sense to find the distance between these 2 points would be the distance formula. I circled that. And I did that because I want to discuss one other benefit of the distance formula. I already talked about the fact that the distance formula is needed because our distances are not always on a coordinate grid. Now, one could argue that some of these coordinates that I've given you, you could go plot on the coordinate grid. However, look at these 2 coordinates. 1/2 and negative 3, and even worse, 4 and 3/4. When you have a tiny grid and it's going by ones, is it going to be easy to plot 1/2? Maybe not too bad, but 3/4, even worse. So the distance formula makes more sense here because it's difficult to plot these fractions on the coordinate plane. Okay, and that concludes our lesson on distance in the coordinate plane today using the distance formula.